Smart Culture, Science.
Let's investigate the effects of intermolecular forces on surface tension. We will start by using a 20-cent coin and carefully adding drops of different liquids to see how many drops each coin can hold before the liquid spills over. So first I will test water. I carefully add drops one by one. You will see that the coin holds approximately 34 drops before the water runs off. Notice how the drops build up into a dome shape because of water's strong hydrogen bonds. Next, I will test olive oil. Again, I add drops slowly, counting carefully. The coin holds 35 drops before it spills. Even though oil is nonpolar, the long molecules still provide enough attraction to hold together. Now I test glycerine. I add drops carefully. This time, the coin only holds about 19 drops. Glycerine is viscous, but the drops break earlier compared to water and oil. Next, I test methylated spirit. I add the drops one by one. The coin holds about 16 drops before spilling. The weaker forces between the molecules mean it spreads out more quickly. Finally, I test nail polish remover. I add drops carefully, counting as I go. This time the coin only holds 15 drops before spilling. Nail polish remover contains acetone, which has weaker intermolecular forces, so the drops don't hold together very well. Now let's observe the meniscus of each substance in a test tube. Let's take a look at water. You will see the shape is concave. The meniscus is concave. What about methylated spirit? Again, you will observe that the meniscus is concave. What about nail polish remover? It is concave. Next, we will take a look at olive oil. Again, you will see that the meniscus is concave. And then lastly, we will take a look at glycerine. Here, you will see that the meniscus is concave. All of them form a concave meniscus because the liquid is attracted to the glass. Next, I place a small drop of each substance on a glass slide. First, olive oil. It forms a round droplet. Next, glycerine. It also forms a round droplet. Then water. Again, a rounded droplet forms. On the second glass slide, I tested the remaining two substances. First, nail polish remover. Instead of forming a drop, it spreads out flat. Methylated spirit. It also spreads out instead of forming a drop. From this demonstration, we can see that substances with stronger intermolecular forces like water, oil, and glycerine form more stable, rounded droplets, while those with weaker forces like nail polish remover and methylated spirits spread out easily and hold fewer drops on the coin.
And that's a wrap on today's fascinating journey through the world of knowledge. Don't forget to hit that subscribe button and join our ever-growing community of curious minds. We can't wait to embark on new educational adventures together.